first presenter is going to be Elias Valladares from CPD, who's going to talk more about the future energy policy trends.
Thank you very much for the invitation. It's I'm here, and thank you, Dora, for putting everything together. It's absolutely great organization. So what I'll try to do is I'll try to discuss the general energy policy trends with a focus on heating, and I will cover mainly domestic, non-domestic, and district heating. And in discussing this, I will try to explain how fuel cells may fit within the long-term energy policy trajectory. And I think this is very important because policy will be necessary to make all these new technologies a reality, because there is not much awareness from those involved in the supply chain, and perhaps at the moment the drivers to take up those technologies are not strong enough, including the fuel cells. A few words about us. My name is Elias Valladares, and I am a partner at Acuity Consulting. We are energy policy experts, and we are based in Solihull. We've been engaged in the policy debate for about 15 years across all subjects related to decarbonization and addressing pollution, but I'd say heat is a topic that we are very passionate about, and perhaps heating is the area where we have most of our expertise. So one way or another, the company has been involved working on all iterations of the building regulations, things like setting up and considering the renewable heat incentive. And we have done this predominantly working on behalf of industry and those companies that want to introduce innovation into the market. Our team is quite diverse, so we're about 20 people strong and growing at the moment. I'd say one thing that differentiates us from other companies working on policy is that our approach is a bit more technical. So we employ economists, we employ engineers, which allows us to sort of speak better the language of the civil servants and those making decisions to change policy that then save the market. So I'd say our base is also diverse. It is predominantly manufacturers that want to launch innovation into the market. Companies like CIBSE Electric, for instance, on heat pumps, fuel suppliers. Then we do work also on behalf of government, so we are involved in the delivery of heat network investments, working with ACE. We're part of the consortium that was recently selected to deliver this. And we do also do work with utilities. Most of the work we do is Westminster focused, so we really like working in the civil service. We're kind of policy geeks. We really like working in the civil service. But we also are engaged in Brussels. Personally, my background is I started working in Brussels ages ago, and also at local authority level. So been particularly quite involved with what is happening in the West Midlands. So there is experience at regional, national, and supranational politics, if you want, which gives us a very good understanding of the debate. So, energy policy, where do we start? I'd say is speaking to civil servants and also speaking to government representatives, the expectation is that the heating market over the next decades, including during the next decades, will have to change radically in order to meet legal targets that are binding For instance, the Climate Change Act and the objectives that this set in 2008. And I think the only way to achieve this is through policy which is visionary. And the problem is that the market will not move by itself. So it is necessary that there is some sort of intervention by government to make this happen, to create incentives to take up low carbon technology, but also through changes in the regulation. So at the moment there seems to be a tendency to focus more on regulation, and there's a feeling that perhaps subsidy is less effective in achieving the objectives. And I'd say a key area is climate policy, as I said before. So the Climate Change Act of 2008 set up carbon budgets that are binding and that the government has to meet every few years. I'd say what is characteristic in the UK is that the government embraces those climate targets. So there was a seminal publication a couple of months ago called the Clean Growth Strategy, where the government said reducing carbon is at the heart of our industrial policy, and actually reducing carbon emissions wouldn't affect negatively growth. As a matter of fact, the government said that out of all the G7 countries, the UK has reduced emissions the most and has achieved the highest growth years. Therefore, one doesn't contradict the other. And it is, I think it's telling that one of the key streams in the government's industrial strategy is clean growth and decarbonization. And there is a lot of appetite to invest in those technologies. And I think what is interesting for us here is that a big share of emissions comes from heating buildings. It's about heating is an area that the government has struggled to address in terms of achieving carbon reductions. So I've taken this from a very recent publication by the Committee on Climate Change. You can see the red line there is emissions from electricity, from power, and there the government has been very successful. The main reason why emissions from power have reduced so much is the phase out of coal. So that's been perhaps the single biggest success of the government over the past 10 years. That reflects in the carbon intensity of the electricity grid as well, that has reduced radically. Although as Kristen said earlier, not on paper. But emissions from heating have remained stagnant. Even over the past few years, emissions from heating have increased. So this is not a success area, it's a very big challenge, and it is very difficult to achieve change in these areas. It's proven very difficult. And these are some of the reasons, these are some of the challenges stated by the Committee on Climate Change. Could be others. So the government has been successful in increasing the rate of thermal insulation in buildings. If anything, these have reduced over the past few years. They haven't been very successful in convincing people to take up low carbon technology. So a lot of money has gone into RHI, for example, but the heat pumps market hasn't moved over the past few years. So despite all this subsidy that's gone out to support heat pumps, the market hasn't embraced for whatever reason. There is multiple explanations for this, but it hasn't happened. Heat networks still using conventional CHP. So the big changes, which is mass deployment of thermal insulation or significant uptake of low carbon heat technology, these things haven't happened yet. And there is a realization that, again, speaking to civil servants, that the government has to do something. And this is because the market has to change substantially by 2050, and including during the next decade, to meet objectives that are binding. So this is just for reference, for instance. There are many studies out how the heat mix needs to evolve, but this is just KPMG's take. They did their energy scenarios in 2016, and you can see there that they expect that hydrogen and electricity, which is two areas that the government at the moment is mostly interested in as long-term solutions for decarbonization, will need to have a significant share. And to get there, we will need some sort of policy or regulation to make this happen. And so this is again from the Committee on Climate Change Communication to Parliament, where you can see that if we just do low-risk policies, we actually might have an increase in emissions. So this is a moment where, or at least in the early 2020s, the government will have to take some risk, show some resolve in reducing heat emissions. And these are some of the areas that the government will have to act upon. I think new build is widely seen as a low-hanging fruit. So there is a review on Part L taking place beginning of next year, and the feeling, speaking to what now is called DHCLG, is that the government will go further than previous times in tightening standards, making buildings renewable heat ready, so that they facilitate the deployment of low carbon heating technologies. There's a sense that more needs to happen in the retrofit side as well, including on trying to go or trying to create such circumstances that will allow to go beyond the gas boiler and create some traction for the technologies that may take us further. So this carbon is a big challenge. What I'd like to throw into the mix as well, which is very relevant to this discussion, is air quality, which is a major political issue. The government's been taken to court for breaching air quality targets, including in Birmingham. So there's a lot of pressure for the government to act, and for local authorities to act. I'd say at the moment it is mainly transportation that is facing this pressure. You might have read about Dieselgate, cleaner zones being implemented in Birmingham and elsewhere, in Manchester, London, and so on and so forth. But assuming that transport will be tackled, I think stationary applications will also be the energy source for a heat network. The London urges developers to consider other technologies as well. They did mention fuel cells in the consultation a couple of months ago, but in the consultation response, fuel cells are not referenced. And I think that might have been a missed opportunity, but 50% of NOx emissions will be from combustion and stationary applications. So I'd say, concluding, and I'm sure Christian will elaborate, in developing all this new policy, why would the government care about stationary fuel cells? but they could be relevant for a diversity of reasons because potentially in terms of efficiency they go a step further compared to conventional gas technologies. They emit very, they have a very low impact, might have a role in the context of a hydrogen future, which is something that the government is currently considering. So in policy terms, this is something that these are some of the drivers that might make policymakers consider fuel cells. And I'd say I suppose the reasons why the government may have to act is that carbon, and this is sort of how the government considers intervening in their impact assessments, is that perhaps fuel cells bring benefits such as reduced carbon or reduced NOx, that if they are monetized, then that makes them competitive because, for instance, reducing NOx has a value because it has reduced impact on the NHS. And these are things that the government monetizes, but the market doesn't. So this is one of the reasons why fuel cell may be considered, and with some cost down, it may eventually become competitive and achieve wider deployment. So this is sort of the policy angle to the debate. But I'm sure Christian will give more information about how the technology really works and its actual application. So thank you very much.
Yes, very interesting points on how the government wants to go forward. Do you have any questions at this point? Go to the second.
Yeah. Specifically the CCC in general.
First, second presenter is Christian from Weizmann. There's been a slight change on the schedule today for the presentation. But he will talk us more about low carbon heating technologies and especially fuel cells. Thank you very much for joining us.
Good evening. So just live and wait for the next few minutes. Yeah, so unfortunately there was a slight change of plans, so I'm not the one you think I should be. So I'm from Weizmann. My name is Christian Engelke, Technical Director in the UK. I'm only half an hour from here, based in Telford. So we are talking today a bit about the fuel cell technology, as Ilias already initiated and discussed, which is obviously the title as well today. But from my point of view, please feel free to ask any questions you have. Okay, this is a very exciting subject which we are right now, which we're in, and we will information for you as we get through. So, just a few words to our organization. We are a private company based in Germany. We are employing now about 12,000 employees worldwide. We are predominantly active in the northern hemisphere of the Earth. Naturally, that's where the countries need heat. So much in the south of Africa, Australia, and South, and there's not much heat requirement. So we are traditionally a heat generation organization, manufacturing organization. We have 23 manufacturing sites. So what we do is we're actually developing things and we're manufacturing them as well. We are not an assembler as such. So we have, luckily for engineers, a very deep understanding of technologies, from gas boilers to heat pumps, renewable technologies, biomass, from small to very big. Very lucky working for this organization, but also very challenging because customers expecting us to remember all these things when we have 15,000 products in our portfolio. But we're operating in about 74 countries, and the UK office is the sales office of Eastman in the UK. So we are selling quite a lot of these technologies in the UK market as well. And a large proportion of our product portfolio is going to the export countries. So yes, so what's so exciting about the organization? We are a family business, as I said. The owner is called Mr. Wiesman, so there's a name attached to every product. And the whole purpose of our organization is to really be sustainable, be a technology trendsetter in this today's world, and also offering our customers a very energy saving and economically friendly solution for businesses and for homeowners. The next thing is that we have a very large product range. This is just a short snapshot. We are covering the whole aspect of the marketplace. So from different fuels, from dirty oil to gas to renewable technologies, solar, thermal, etc. That's what we do. We are offering heating technologies, industrial solutions in renewables, and for every application as well, from domestic all the way to district heating schemes. We do have the right solution there if customers wish to use our solution, to use them. And heating technology, as I said before, this is the biggest part of the organization, the heating division, and you can see that we have a good range of different technologies, say from gas boilers to oil, hybrid technologies, heat pumps, biomass technologies, and so on. So quite a lot to choose from, which makes our products a bit different to say in some respect. This here is not to scare you off, but I think I noticed there's a little gentleman sitting in the audience as well. It may affect him in a few years' time. And this is all what it matters. Ilyas mentioned as well, it's the climate change. I don't want to go into the political discussions about it, but it is what it is. It is high on the agenda. All the European countries have signed up to some form of a reduction of carbon and fossil fuel to more or less save the planet, save the generations, and making sure that our next generations of children will still have a place to live. This is a map that was sort of drawn up by some scientists where Europe could end up by 2080 if water levels continues to rise due to various reasons. And you can see that we're all hugging ourselves on the hills of Wales and Scotland probably to make sure that our feet are not getting wet and with northern Germany and Denmark, the coastlines are completely submerged in water. So it is a very important subject which we need to cover, but because it's so far away from us that most people are not really jumping on this one. And Ilyas was very grateful to mention the policies aspect there of government doing. But if I'm quite honest with you, and if you're honest with yourself, end users probably do not know what we are planning to do, why we're doing things. End users are only looking as closest to their boiler in the bedroom or in the staircase, wherever the boiler is. Hopefully next winter the boilers continue to run. If it's not working, if it's broken down, they want the cheapest replacement as much as possible. People do not really think oh, I need an energy efficient technology putting in place, or I need to save carbon because I want to save the world. This is unfortunately the reality. There are 27 million homes in the UK, many more homes in Europe, and every person is the same. I'm the same as well. I would rather spend 1,000 quid for a boiler replacement rather than 10,000 quid to save some carbon in there. And that's unfortunately the reality. But the discussions we have with the government is actually pointing that one out to them. And the government is in a dilemma to either, what we call it, able to pay people, and those to set policies in place to force certain people, like house builders, to move into a higher technology or more energy efficient technology. So it's a very, very important subject. So we are trying now to resolve the solution. And we are a manufacturer. Government coming to us and say, come on guys, what is the next technology after the beloved gas condensing boiler in everybody's home? So we have to sit down there, and the government is giving us targets what we need to achieve. Carbon reduction, fossil fuel reduction, more renewables, etc. So we're sitting down there and we're coming up with some ideas what we're going to do. Of course, as a manufacturer, we would like to sell it as well, but we need policies, we need backgrounds to do it. On the fossil fuels, on the fuel cell technology or CHP technology, as it is, the whole discussion point came about from where we are now. In today's world, we are just changing, but sort of historically, or maybe only a few years backwards, we had a very, very clear view of how we're making things. We have large power plants, they burning lots of dirty stuff, coal, gas, etc. Maybe some nuclear power plants, and then we have our distributors, and then they're distributing the electricity to the individual homes, and we're consumers. So that was the very simple model. It worked. We plugged our electrical equipment into the socket. We get power. We have lights. Christmas tree is on. Everything is fine. So, but the things have changed now. So we have more renewables technologies in places. As we say, the UK have invested heavily in wind farms, in photovoltaic system, etc. So the electricity grid has become much greener these days than it was a few years ago. However, it came to a very price as well. The problem is now that distributors manage those peaks and troughs of electricity generation. So we have large wind farms scattered around Scotland, for example. How do we get the electricity to the consumers living in Liverpool, Manchester, Sheffield, London, etc.? It's a long way for electricity to travel along the wires. The Welsh population do not like putting new pylons up there to get the electricity back to Birmingham from their coastline. So there will be an issue there. There will be pockets of areas, clusters in the system where the grid is becoming unstable, and these poor people really have to manage it. So smart grid and smart metering, all these things you probably heard as well, are meant to be part of it. And also then in the future, consumers are also then, that was the whole point, is becoming producers. Yeah. So we have now, some of you may have seen it, we have PV panels on individual roofs, and they're fantastic, but PV panels are great in the summer, daytime. Not much electricity is going on in daytime. Maybe the fridge is running, but in the evening, that's where you need lighting, you need televisions, etc. But PV systems don't work. So we have distributed peaks. Electricity also becomes more expensive, naturally, people investing into new technologies. So therefore, electricity storage devices are now becoming sort of the flavor of the week, the month, etc. Storing energy is a problem right now, because 14 pence average homeowner pays at the moment for electricity per kilowatt hour. Storing a bit of electricity makes it very expensive. But there's different technologies involved. But why are we doing, you say, micro CHP technology? So as I say, it's a technology which we are, as a for a homeowner, you're in a position to not only making your heat for space heating and hot water, but from the same device you're producing electricity. So the advantage from the homeowner's point of view is that you have creating your own electricity as a base load throughout the year, in the night, in the winter, in the summer. So we have a much more stable production. The grid producer loves it because we are taking some pressure away from the grid systems as well. We also trying to promote this fuel cell because as a transition period. Elias have mentioned as well, hydrogen is now a big thing. It's not in government's views. Hydrogen is many years away. It's a starting point. Fuel cell technology is available today, and we are believing that the transition is introducing technologies which are giving us the next few years as a transition period are very important. So, but again, also it sets the ground level for new technologies, new developments, and therefore it will create jobs as well in farming facilities, etc. But most importantly, from the homeowner's point of view, is that there are potential savings to be made for them in terms of producing, generating their own electricity rather than buying the expensive electricity from the grid. So that's the fuel cell, one of the purposes there. We've probably heard, and I know CIBSE have done some papers on technologies a couple of years ago, and sort of trying to explain some benefits there, also comparing against different other technologies. Like the Stirling engine. A few years ago it came to the marketplace, manufacturer has sold it also in the UK. And it was sort of a starting point. That's where the government also picked up on this technology. Stirling engine, unfortunately, is now already has passed its end date. I think from the manufacturing point, I have to say that even the Stirling engine was only a transition technology from us. Our end game as a manufacturer was always working towards a fuel cell technology because of its efficiency, and most importantly is the heat to power ratio, which is so critical for any property. We are basically any electricity making generator generates also heat, and that heat has to be absorbed into the building. And the whole point of having a micro CHP technology in the house is because of the total efficiency. We're talking about over 90%, rather than 35% from the grid, let's say. So, fuel cell has got the very big advantage of a heat power ratio of 1 to 1. Stirling engine 8 to 1 ratio, which is the reason why that didn't work really in the marketplace. It also was quite noisy, high frequency noise. It woke people up in the night, pipe was shaking. So it was the wrong product for the market really. It was more for commercial application. And the other one is the combustion engine on the left. This is the one which you probably see on the commercial world. We're calling it CHP technology. Have got a traditional gas engine fitted in. Very effective for commercial applications, not so effective for domestic. You don't want to replace or change the oil in the filter in the domestic application. People will not accept that. That you're turning up 3 times a year. Commercial application is a different story. Very effective technology on the commercial world. But yes, you have very high maintenance costs. So the fuel cell was always the bit which was from the behavior, from the efficiency point of view, the heat power ratio was the most optimum solution. But it was expensive to make. In today's world, there are 2 types of technologies now in the market on the fuel cell. One is PEM fuel cell, polymer membrane exchange or exchange membrane fuel cell technology, which is a low temperature fuel cell, and the SOFC, which is a solid oxide fuel cell. I don't want to go into the technical side of it, but these are the 2 significant technologies now sort of being established in the marketplace. Solid oxide, high temperature, really more for commercial application. It has to run for 365 days a year. It's not really ideal to turn it on and off. PEM fuel cell is the one which is really more interesting for domestic application. Very low maintenance, hardly any maintenance at all, but can switch it on and off when there's no heat demand. So people going on holiday in the summer you need to turn this machine off if there's no demand, and then and that you can do it with the low temperature fuel. So there are all technologies there which are appropriate and proven now these days. This is just giving you a short example of why we are going to this fuel cell technology. Just quickly to make you understand this graph there. This is at the bottom of the axis is the building heat load requirements. So the further we go to the left, we are talking about very efficient buildings, very low energy demand, very low water demand, and the more you go to the right, we have very high demand, energy demand. So you can say new build, old building, Victorian style, 3-4 bedroom house, very high energy demand. The Stirling engine, which is the green line there, you can see that the Stirling engine on the left hand side you see the y-axis there. That is the annual electricity generation from those technologies. So the green line there is the Stirling engine, and you can see that this technology actually is peaking its output performance at very large buildings, commercial buildings, 30,000-40,000 kilowatt hours a year and higher. Then you are generating the right amount of electricity of 4,000 or 5,000 kilowatt hours a year. The fuel cell technology, particularly the one is the PEM fuel cell, the blue one. You can see that technology is actually being suitable for low energy homes. So you can have it for new build, you can have it for small properties in the UK, or for larger properties. So currently this technology is employed from small to big. It's covering, I would say, 80% of the UK housing stock, in theory, in the way it's been used, been designed, and you can turn it on and off. The red one is the high temperature solid oxide fuel cell, and again you can see that is more applicable for larger properties again, and we'll be using it for small businesses, etc. So that is the 3 points why the fuel cell has been earmarked as the most applicable technology for residential properties in this world. Going further, yes. So again, we have traditional power generations currently have got efficiency of about 38%. So that means from the primary energy factor point of view, the energy we're putting in there in terms of making electricity or putting wind farms up there, etc., the efficiency with the losses in the cables, etc., transmission losses, and we're talking about 38%. The total efficiency of a decentralized micro CHP technology, of a fuel cell technology, is more than 90%. And you can see, interestingly, that if you just look at the electricity point of view, a fuel cell, micro CHP, all the power, the grid power, the efficiency is very much the same. The key point is why this technology is so efficient is because of this little bit of heat it generates. You're using it for heating and water. You cannot dump it. I mean, the number of comments I have from people say, oh, I put a dump radiator in the garage, so I'm forcing the machine to run. Wrong thing to do. We are not dumping any heat. If you dump the heat, your efficiency drops straight to 33%, and that's not what you want. And then people complaining that their gas consumption is so high and they're not really getting most of it. So that's the whole point. We are utilizing the heat, a little bit of heat from that electricity generation, as well as making our own electricity on the site. That is the whole story of this type of thing. So again, we are supporting the energy transition period. We are living in a world where condensing boilers are the norm these days. They are of existence for the last 25 years. So since I came into the industry, that was the time when condensing boilers were first developed, and since then the industry has not moved on. Yes, we were tinkering around with some solar thermal panels, some heat pump, and as Ilya said, so far, and I disagree with his comparison of market 5% is renewable in the UK. I think it's 0.5%. If you look at from the true point, 1.6 million gas boilers are sold or heat generators are installed every year. 97% of that is gas. And that has not changed for the last 12, 15 years. It was always the same. So we are offering a solution there to making the whole house energy aspect, efficiency point of view, make it efficient and more efficient. And that's what we're trying to do with fuel cell technology. So a typical residential product, we're not mentioning any names on here, but it gives you some key values in here. Here we're talking here about a 750 watt fuel cell generator built in there with a thermal output. That's the one. That's what I mean that the fuel cell just generates a bit of heat through the processing and reformer aspect there. Only 1 kilowatt though. You can see 1 kilowatt of heat doesn't sound a lot, and it's not really a lot. And you can easily sort of disperse it into your existing heating system, into hot water, preheating hot water, etc. It works very well. We are achieving about run hours of the generator of 6,000 hours a year. Now we all know a whole year has got 8,460 hours. So running a fuel cell at 6,000 hours is a good go. A Stirling engine probably would only run for maybe 2,000 to 3,000 hours a year. So that's the key benefit of this. So efficiency is 90%. There's some maintenance involved with the fuel cell, but it's not very much. It's limited to filters, changes, air filter change, or deionization water filter. Very little maintenance at all. The gas boiler, which is a peak boiler, next to it, that's a modern gas condensing boiler there with full-blown weather condensation controller there, very, very efficient. That requires still, according to the UK recommendations in annual service. So that's what we have. So the thermal peak output for this package is 19 kilowatts or 6 kilowatts for what you need to do. And as I say, it's suitable for properties of a large variations from very small to fairly large properties. So that's that. And now, just very quickly, I'm talking to you about the fuel cell, what we do with the fuel cell. Now, the fuel cell has got also some other advantages. We are not dealing with moving components in the fuel cell. It's a chemical or electrochemical process. So, if you maybe cast your mind back to the GCSE times when you went to school, we have chemistry lessons, we have physics lessons, etc. All this, what you've learned many, many years ago, or maybe you're learning it now, you have it in the fuel cell technology. So what we do is we're using the natural gas from the grid, which is readily available. 90% of households are connected to the gas grid. The gas contains, calling it CH4. The gas is going to a reformer inside the fuel cell, and with that reformer we're injecting steam into this. Steam is water, and that reaction will then cause that we splitting the molecules from methane into hydrogen and CO2. And the CO2 will be then going into the fan, into the exhaust of the product, and the hydrogen is being utilized. Then we are pulling in air from the outside, oxygen, that's what we're all breathing in, and the fuel cell stack, which is what we call a battery cell, but it's a battery cell which never discharges itself. The hydrogen with oxygen, and as we know from physics, hydrogen and oxygen, if they're trying to get together, they're very reactive, very aggressive. And from that process point of view, we are then generating DC power in that battery. And that DC power is then going to a converter, which then converts it to AC power, and then it's been connected to the household grid. So the bit of heat created on this is going to a heat management system. We're calling it plate heat exchanger, buffer vessel, restoring that heat in forms of water heat, and that's been then used for preheating your water for showers and bathrooms, or you're using it for space heating. And that's all what it is. So it's a 4 very key building blocks in that machine. If you ask me the question, well, what about the hydrogen? If the government goes to a hydrogen grid, you can see the gas reformer, that's the one which we use right now, because we do not have a hydrogen grid. It doesn't exist right now, so we have gas, that's readily available. But if we do have a hydrogen grid, in many, many years maybe to come, perhaps, if the government is happy to spend this huge amount of money, then you can see that obviously a large proportion of the cost of the fuel cell could be reduced by removing the reformer from it and then having just hydrogen in the grid straight into the fuel cell. So that's a process. Goes along. The fuel cell stack itself, again, we stick with our chemistry lessons. It's just a little picture there. We have the plates, just a stack, it's about that big. Lots of plates in there. These plates are coated and defined in terms of an anode in the cathode, positive and negative pole. Then basically moving the positive electrons are going through the mesh filter, and the negative electrons is then doing what the definition of electricity is all about. It's about moving electrons. We are picking up then the direct current there from light bulb, and then on the other side we have as a waste product there the hydrogen molecules are then getting together with oxygen. The waste product is water, just water. We are recycling that water for our injection process in the reformer later on, so there's no real water top-up required, it's all self-contained, and that's the whole process. So you can see, this is what you see, this is what it is. There are no moving parts involved, there's no noise level involved, and the key benefit of the fuel cell technology is it doesn't generate any NOx. That's a key benefit also from the government point of view. There's no NOx generated, like with combustion products or like our gas boiler. It is all NOx free. So again, here for our engineers here, this is the chemical reaction formula down there. So we have 2 parts of hydrogen plus 1 part of oxygen feeding it into the battery stack, and we get 2 parts of water out of it and power, DC power. That's the process. That's the way it works. I have to say, from the experience which we have, it's a very reliable process as well. It's reliable because it's a chemical process. It's as reliable as it is. And I'll just give you some examples in here of some installations in the UK. There is, as you can see, there is a mixture of different properties there. An old property in Scotland, for example, a big property. It had a very old boiler there. It was on the EPC side of it. It was we are estimating that this homeowner will generate 4,200 kilowatt hours of electricity, which is more or less the same as what the household actually needs as well. So we're generating as much of electricity as the household needs for the year. So then we have another property there. Again, this is the old farmhouse in Herefordshire. Again, very big property. And again, they used a fuel cell with a large hot water cylinder, and this machine has been running ever since, and we think that maybe it will probably top our best list in terms of 5,000 kilowatt hours of electricity generated per year. This property was predominantly fitted on oil. Luckily, they have a gas pipe on site, so we connected them with fuel cell there. So then we have also a few solid oxide fuel cells installed in the UK. St Andrews University, they were very keen to have a few of them. They actually installed 5 of our solid oxide fuel cell. And they are sort of heating up buildings from the St Andrews University. So there are few technologies of that type around, and they're all doing what it says on the tin. They just run and run and run, and everybody is happy. And the biggest benefit is that people are reducing their electricity significantly. Good. So finally coming to the end. Now, other benefits, other new customers for this type of technology are what we're also talking about are the electric vehicles industry. This is an ever-growing market, and most consumers who bought an electric car didn't realize that the electricity goes through the roof if they have got a charging point at home. And that could be significant. Up to 3,000 kilowatt hours will add to homeowners' electricity bills with an electric car if they're charging it at home. So, for people who have got it's fantastic news, because the electric car will add to the base load of the property, and therefore it will maximize the use of your own generated electricity in the household. Fantastic. So therefore, instead of people say, oh, you're exporting lots of electricity, I want to use it more. Yeah, that's maybe fine for some properties, but some others who have got a high electricity consumption, with electric car, it will actually be much more benefit, and therefore electric cars at home will be an additional bonus for them. Then, as I said, this technology is obviously expensive as well, and we need to convince end users to pay the extra money for this. Luckily, we have still Europe on our side, and Europe will provide us European fuel cell and hydrogen group, have giving manufacturers quite a lot of money to support the rollout of fuel cell technology. It's called PACE, a pathway to competitive European fuel cell in the micro-CHP market. They're also supporting stationary fuel cell technologies for powering IT centers and telecom masts, etc., etc. That funding helps us right now to offer this technology to a, let's say, more tangible price to customers. That funding is limited, obviously. We've been giving lots of money, and we have to, in return, that we are installing so many products of this in a certain period of time. The idea is, again, with any investments and funds, that obviously it helps manufacturers like us to support the market with new technologies, bring them into the marketplace, generating a higher production turnout in terms of, and that helps us to reduce manufacturing costs. As I said, the total European market for gas condensing boiler is more than 5 million boilers every year will be installed. Now, the economy of scale for manufacturing condensing boiler is at the lowest point now ever. People doing anything. Micro CHP and fuel cell technology, we're just at the beginning of this. So there's only a few thousand models being installed right now. So you can see where the cost difference comes in. So we are relying on certain incentives to help to push it in the marketplace. That's where PACE comes in, quite handy, and it helps us in the funding. Certainly for us, this one is still available until hopefully end of next year, and if we're lucky, maybe a bit longer. It depends how many of other manufacturers are able to sell their promised volume. So there are other manufacturers involved in there, but I can tell you right now, there's two only of those numbers were actually up right now. Okay, so there may be some money left in the pot for a bit longer, but as you can see, there is a huge institution behind it to support this type of technology across Europe, and which makes it very important and very exciting. In addition, in the UK, we know about the MCS side of it. The government is the government right now is supporting micro-CHP technologies through the FIT tariff. So we all know FIT through PV systems, and micro-CHP are linked to this right now. There is still some money left in the pot, and that is an additional incentive for homeowners. Okay, so just to give you an example, homeowners could earn up to £7,000 in 10 years with FIT having this machine installed. So that's not a number which we need to dismiss. It's very important for lots of homeowners to make use of this system. So the technology is on the MCS data listing and therefore available. Another exciting aspect there is the EPC rating. So the technology is on the EPC database as well. It helps customers, homeowners, maybe landlords, perhaps, to lift the EPC rating of the property without really touching the building fabric. Yeah. So this is an example. I'm a lucky user of this technology in my property. I had an F-rate property before that. Assessor came in here, spent about 2.5 hours in my property, got through it, trying to make sense of the technology. I have to say it was very good. And you can see that micro cogeneration is on the EPC listing. We found the technology. I got full marks for heating and for water. And unfortunately, it didn't accept my double glazing windows, it didn't accept my solid brick door insulation, etc., because it wasn't rubber stamped. I haven't got a certificate for it, blah blah blah. But the news is that it has lifted the property to a type C. The property I'm living in is 110 years old. So I think thanks to the technology, it just helped as well. It is recognized in the EPC database how valuable this user technology is. Again, and that makes it so special. So homeowners benefits, as I say, independent of rising electricity prices, very key for homeowners. They're not bothered really about carbon savings, etc. They're not that many trees paying the extra penny just for nothing. People want to see hard cash. So the incentive scheme and the electricity saving they see on the property is a huge motivator for lots of properties. Yes, if you want to talk about CO2, currently it does save up to 40%, but as we said earlier on, the improving carbon intensity of the power grid will make that number a bit less, but again, from the homeowner's point of view, not so critical, maybe from a planner or new build planner point of view, more. And again, I like to use it, although I shouldn't really use it, but I find also that lots of homeowners and house builders don't really like PV panels on the roof because aesthetically it destroys the appearance of the property. Maybe the roof is not big enough, but the performance of the fuel cell is equivalent to about a 5 to 6 kilowatt peak installed PV system. So it's a massive PV system, 30 square meter. So not many houses, domestic houses, are actually going that high. I think the maximum is less than 4 kilowatt. And then speaking with smart, we have there are smart technologies in there involved in this one. Homeowners can remotely brag to their friends in the pub about how much electricity they have generated themselves, etc. So very, very interactive system. But most importantly, from the homeowner's point of view and from us, is that through that PACE funding, which I've mentioned before, we are obliged to offer the client a full remote monitoring service. Okay, so the people are quite, how should I say, are cautious. That they're spending lots of money on this one, and our message is that we are obliged to support them for the next few years to come. So we can see their property every day. We can see it on the phone. We can see it on the computer. We can even make remote adjustments without actually turning up. This is great. So many stories in the winter where we can tinker around with their settings, and next morning they're phoning me up and say, "What have you done? It's nice and warm now," or "Isn't it? It's not working." Blah, blah, blah. So it's great. So I think the interaction between homeowners and the manufacturer is as close as it can ever be. Good. So, and I think I'm coming to my end now. So if you have any more questions, please fire up, and then. Yes.
You seem to be dancing around the subject, but what is the payback compared to a condensing boiler?